Okay, this is the makeup video because apparently Friday, the 11th, November the 9th, was a absolute train wreck, so you didn't learn anything. So I gotta teach you a few things, because if you don't understand this, then you're not gonna understand any of the videos that you're supposed to watch for homework tonight, and we'll just be behind and everything will be terrible. So, here's the highlights of what you need to know. We are starting ionic compounds. That means we're taking two elements, we're putting them together. When you have an ionic compound, you have cations and anions. Cations are the metals, anions are the nonmetals. Okay, I will also try to post my PowerPoint on Edmodo. I can't post it on YouTube, but I'll try posting it on Edmodo so that you can go through the PowerPoint yourself also. When you have a cation with an anion, the cation is going to give an electron from its valence shell, one or more electrons, to the anions. And the anions are going to keep it. And that will give the cations a positive charge and the anions some kind of negative charge. If you give 2 electrons, it'll be a positive 2. If you give 3 electrons, positive 3. If anions take more than 1 electron, they can have a higher negative charge there. So let's draw what that's going to look like. Let's say we have rubidium and phosphorus. Rubidium is Rb. So let's draw this atom. And here's its electron. Rubidium is in the alkali metals. It has, so it's over all the way over here on the left-hand side. So it has a +1 charge, meaning it wants to give away 1 electron. So here's its 1 electron that it wants to give away. Phosphorus is a -3 charge. If you look on your periodic table, so that means it wants to take 3 electrons. We're going to represent that with these 3 holes here. So this rubidium is going to give its electron to phosphorus to fill in that hole. Well, that's great, but phosphorus still has 2 more holes to fill in. So what are we going to do? We're going to need another 2 rubidiums in order to fill in all the holes. So the goal of ionic bonding is for all of the cations to be able to give away all the electrons they want to give away, and for all the anions to be able to take all the electrons they want to take. And you may need different numbers of anions and cations to make that work. All the electrons have to be given, all the electrons have to be taken. And then we have 3 rubidiums for every 1 phosphorus. So we're going to write the formula Rb3p to show that the ratio of rubidium to phosphorus is 3 to 1. Ratio. 3 to 1, rubidium to phosphorus. So these subscripts here at the bottom, this is like super key point right here. The subscript at the bottom of the formula is the ratio of cations to anions. Let's do another one. Excuse me. Let's say that we have beryllium and oxygen. All right, so beryllium is in the alkali earth metals, so it's got 2 electrons in its valence shell that it wants to give away. Oxygen is in the -2 column, so it's got oxygen. It's got 2 holes that it wants to fill. So beryllium is going to give its 2 electrons. Oxygen's holes are filled, so beryllium and oxygen is a 1-to-1 ratio, like this. So you don't necessarily have to have a subscript there. Just like in math class, you don't have to write 1s. If you write a 1, it's not necessarily wrong, but you don't have to do it. Okay, so any 2 atoms that I give you, I can give you a cation and an anion. You can figure out, based on the charges that they have written on the periodic table, you can figure out how many of the cation you have to have for how many of the anion. You can draw that out if you like. If you're a visual person, you can draw it out and figure that out with the electrons and the holes. But let me show you a mathematical way to do the same thing. So let's say that we're going to do rubidium and phosphorus. We can just write the charge below it, +1, -3. This indicates how many electrons to give or take. So this tells me that rubidium wants to give 1. This tells me that phosphorus wants to take 3. We need to get the lowest common multiple for these numbers. And the lowest common multiple here would be 3. In order to get to 3, we have to multiply this by 3. I'll get give us positive 3. In order to get to 3 here, we're going to multiply this by 1, and that'll give us negative 3, which is 0. This tells me that all the electrons given are taken. So this row indicates total electrons given and taken. If this comes out to 0, we did it right, because that means all the electrons that are given are taken. So then this row in here, the number we used for the multiplication, that is how many atoms are involved in the exchange. This is our subscript. So then I would call this RB3P1. We don't have to write the 1, that's terrible. We don't have to write the 1. So this is how you write the formulas for any ionic compound. We had the cation and the anion. Always, always, always put the cation first. So if the anion is listed first on the practice slide or something like that, just got to switch them around so the cation comes first. If you want to write the name, let's say you have a formula. Let's say we're going to do this formula, beryllium and oxygen, and you want to write the name of this. It's super easy. First, you write the name of the cation. Then, you write the name of the anion as a separate word. However, for the anion, you have to change the ending to "ide." So this becomes beryllium oxide. This one would be rubidium phosphide. We change the phosphorus, we take off the orus, and put on "ide," rubidium phosphide. And that's all you do for naming. We will practice more writing formulas and writing name in class, but the other 3 videos that you're supposed to watch for homework this weekend are taking this concept and going further with it, so you need to know the basics before you watch those other videos. And I will, like I said, I will try to post my PowerPoint onto Edmodo when I get home tonight. Thank you.